Hey guys, my name is Mike, and in this video, I'm going to show you how to analyze and improve your AI agent harness entirely on your own machine using the free and open source HALO desktop app. So I'll explain how HALO works, and then we'll dive into a demo of the entire platform using real agent traces from a deep search agent that we built and ran. We'll walk through the setup, inspect the agent traces, run HALO to identify the recurring problems, and then hand the resulting report directly to a coding agent to implement the fixes. So before we dive into the app, let's quickly take a look at how the full HALO loop works and why you would want to use it. HALO uses a recursive language model, also known as an RLM, and it's an approach designed to break a very large set of information into much smaller pieces in order to analyze them independently and then combine those results up the chain into a higher level conclusion. So this really matters for things like agent traces because an agent running at production scale can generate far more context than a normal coding agent like Claude Code can reliably reason over at once. It's hard to find systemic issues and patterns when you are just limited in context that way. So we found that using an RLM was the best approach to this problem. But the actual workflow that you need to know is pretty simple. The first step is just sending traces into the platform, and this can be with our trace library, LangFuse, Phoenix Arise, or even just a direct JSON-L upload. And once those traces are in there, you can run HALO on them, and it will produce a report with the specific recommendations on how to fix your traces. So with that report, you then can hand it to a coding agent to apply the fixes, or you can just use that information to review or apply the fixes manually yourself if you want. From there, just rerun the whole thing with new traffic to confirm the improvements and then repeat as the product grows. That's the whole loop. So the desktop app that I will be showing you today lets you run this entire workflow locally on your machine. There's no account needed. There's no sign up. It's completely free to use. But if you like the product, we also offer a fully hosted and managed version on inference.net. And it's just a little better suited for production applications that are running at scale. So to install the desktop app, all you need to do is run this command right here. And we support Mac OS and then the most common Linux distributions. So once everything is installed and running, you'll be taken to the onboarding screen. If you already have traces, you can upload them directly to the app. We also support various platforms such as LangFuse or Phoenix Arise. And if you want to connect a general live agent and send your traces in real time, these are the endpoints that you will need to set. If you don't have any tracing installed at all yet, you can read our documentation on how to install our tracing SDK. And we have an agent skill that will analyze all your code and then set everything up for you. But for this video, we are going to use the demo traces here. And these are from a deep search agent that we built, which is also available on GitHub if you want to look at the code. And the traces are hosted here on Hugging Face. So all you need to do is hit load traces, and that is going to kick off downloading them and putting them into the platform. Once your traces are in the platform, you will be able to see them in the data tab, and you can filter these traces however you like. You can search for specific ones, and you can also see some high-level data about all of your agent traces. You can click into each individual one and then see all the different steps that your agent run took, as well as how long each one of those was, as well as the cost. If that information is included, you can click on the conversation. And since this is just a search query and a response, there's not much here. But if there was a lot of back and forth between a user and an agent or an agent and another agent, this is where you would see that. And then you can come in here and see the output from all the different tools, chat completions, etc. So the other important tabs are the imports tab, and this is just where your imports are. If you imported traces directly into the platform, you can see the state that they're in, as well as import more data if you have more. The other important tab is the settings tab, and this provides some high-level info on your installation and then various other actions such as updating Halo or also clearing the current telemetry if you just want to start over. But the most important button on this page is the Add Provider button. And since this is the free version of the product, you do have to include your own API key for the LLM that reasons on your data. And this is required for the Halo analysis to work. So all you need to do is click this button, which will open the modal, and then you can select the provider that you want, change the base URL, even give it a name, and then paste your API key. And this is stored completely locally, and it will never leave this machine. The analysis tab is where you can actually run Halo on all your traces. And all you need to do to kick off a run is open this modal. Then you can set filters so Halo only runs on the traces that you want it to. And make sure that you select all time because it filters based on the time that the traces were created, and our demo data was from the past. So it won't pick up those traces unless you set the window to be all time. I'm going to leave the rest of that as it is. And since we already set up our provider, it's pre-filled right here. And all you need to do is select the model. And so I'm going to do GPT-5 mini. You can also add a new provider here if you want to as well, but we already did that on the settings page. I'm going to give a title to this prompt. And we do provide a default sensible prompt here, but you can really change this to be anything that you want. And Halo will use this when analyzing all of your trace data. So you could ask it which agent runs were the most expensive and why, or which ones took the longest, or which ones were users frustrated in. It can really be anything that you want it to be. So I'm just going to use the default prompt here, and let's kick off the run. So that is going to run, and it takes about 10 minutes, depending on how long your trace data is. So once that completes, you'll be able to see the report right here. And for our prompt on finding errors and reducing latency, we got a couple good insights and suggested fixes. So we have tool argument mismatch, search pipeline is error prone, too many sequential LLM calls, a serial external IO that could be paralyzed. All good stuff that could be used to improve this search agent that we built. And so here is some high-level info at the bottom for the highest ROI. The more detailed and descriptive your prompts are, the better the results are usually. And you can run Halo as many times as you want with different prompts, so it may take a couple tries to get exactly what you need. You can also continue the conversation after a run to ask various follow-up questions to clarify certain things, and you can do that right here. And once you're happy with the report that you got, the next step is to actually implement these fixes in your code. So all you need to do is hit copy prompt if you just want to copy it to your clipboard, or you can open it directly in your favorite code editor. So I'm just going to run this in Claude Code on the deep search agent that we built. You can find this code in GitHub if you'd like to clone it and run it yourself. We have both a TypeScript version here, and then we also have a Python version. And this was the code that generated the traces for the demo data that we used earlier this video. So the report that Halo generated is directly meant to be run on this repo. So I'm just going to paste our copied prompt into Claude, and it'll kick off and hopefully improve our agent harness. And that is going to run. See what happens. So Claude finished running, and as you can see, the fixes were implemented, and we now have a new and improved agent harness for our deep search agent. In a production application, you would test this and then keep running Halo as new data and new traffic comes in. On the hosted version at inference.net, you can set Halo to run on an interval, like every week, every couple of days or something like that. You can also connect to your GitHub repo so Halo can analyze your code as well as the traces. You can use any of the models on our platform, and you can also get support when you need it. This free and open source desktop app, though, is a great way to experiment and run these kind of like one-off tests on your trace data. So that's it for this video. There is a written guide on this at docs.inference.net. If you want to use the hosted version, you can sign up on the inference.net website, or you can reach out to us if you have any questions. Thank you so much for watching, and happy coding.